The standard form of a quadratic equation is ax squared plus bx plus c. A is always the number in front of the x squared. B is always the number in front of the x, and c is always the number that doesn't have an x. If it was minus something times x, the subtraction sign would be attached to the b and it would be a negative value. These graphs look the same as quadratic equations graphed in vertex form. Some of them open up, some of them open down. The a value, just like with vertex form, the a value tells you whether the graph is going to open upward or downward. So a controls, if a is positive, the graph opens upward, like the graph that you see on the left. And notice they even say that right here. A is greater than 0, it opens upward. If a is negative, the graph opens down, just like the graph on the right. A will not equal 0, because if a equaled 0, it would not be a quadratic function, it would be a line. Okay? A also controls how wide or narrow the graph is. A has the same job whether we are talking about vertex, standard, or intercept form. The a value will do these things in all of the forms that we look at. The axis of symmetry is still the vertical symmetry line. The difference is we can't see what it is in the function because we don't know what the vertex is from the function. So to find the axis of symmetry, you might want to write AOS next to that so you know that AOS is the abbreviation for axis of symmetry. To find this, you do x equals the opposite of b over 2a. Do you notice that I said the opposite of b and not negative b? If your b value is negative, you put in positive. If your b value is positive, you put in negative. So I really want you to practice when you say it, make sure you say the opposite of b over 2a. The axis of symmetry also gives you the x value of the vertex. Because the vertex is on the axis of symmetry, whatever the axis of symmetry is, that is the x value of the vertex. So that starts this. The vertex, the first part of it is the axis of symmetry value. And then you would plug in the axis of symmetry value to get the corresponding y value. So if you do opposite of b over 2a and say you get 4, your axis of symmetry is at 4. You would plug 4 into the function to get the corresponding y value, and that would tell you where your vertex is. We will do that in an example, I promise. The maximum and minimum. The maximum and minimum value is the y value of the vertex. Take a look at the two examples at the top of your page. If your graph opens upward, the vertex is at the bottom. That would make this a minimum. The y value of the vertex is the minimum. It's the smallest y value that exists on the graph. If the graph opens downward, then the vertex is a maximum. That is the largest y value that exists on your graph. So it's a maximum if the graph opens downward. It's a minimum if the graph opens upward. And you might think, oh my gosh, that's tons of stuff to remember. But if you just look at the picture of the graph, if the graph opens upward, then that is obviously a minimum. If the graph opens downward, then that is your maximum. The one really nice thing about standard form is the c value. The c value is the y-intercept. And it's kind of nice because in standard form, nothing is very obvious except c. C is where the graph crosses the y-axis every time. I'm going to color code as I do the examples, so those of you who are visual learners, if you see what color I did the work and what color that is on the graph, that might be helpful. The first thing that you should do is figure out what is your A value, what is your B value, and what is your C value. So what is A? 3. What is B? -6. If there's subtraction before your B value, attach that negative to the B value, so -6. And our C value is 1. Our first step then is to find our axis of symmetry. And I'm going to try to say x equals opposite of b over 2a as many times as possible to get it stuck in your brain. X equals the opposite of b over 2a. 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 Since our b value is -6, we need to do the opposite of b, so we will plug in +6 over 2 times our a value of 3. Do the multiplication on the bottom first. 6 divided by 6 is 1. So our axis of symmetry is x equals 1. Draw in a dashed vertical line at 1. That vertical line is not technically part of your graph, but it helps you because it shows you where that symmetry line lies. Your second step is then to find your vertex. The x value of your vertex comes from the axis of symmetry. Your vertex is going to exist on this vertical line. Every single point on this vertical line has an x value of 1. To find the rest of your vertex, you are going to plug 1 into this function. So 3 parentheses squared minus 6 parentheses plus 1. I put parentheses directly around wherever the x is because then stick that 1 in there and then plug the whole thing into your calculator. If you know that you aren't very good at PEMDAS, you really should just plug this into your calculator. So 3 parentheses 1, closure parentheses squared, minus 6 parentheses 1, closure parentheses, plus 1. Some of you are really great at mental math and you don't need to plug this into your calculator, but some of you, for whatever reason, you don't do PEMDAS correctly, even now. So you have to square the number before you multiply by 3. So 1 squared is 1, 1 times 3 is 3, 3 minus 6 is -3, -3 plus 1 is -2. So if you plug this into your calculator, you should get -2. So our vertex is the point 1, -2. And I'm going to go ahead and label my vertex on here. Step 3. We need to find our y-intercept. And this is the easy part. Our y-intercept is c. What is our c value? 1. So our graph is going to cross the y-axis at 1. And to help you out, I'm going to write in here c equals 1. Anyone want to guess what we're going to do now? Reflect that y-intercept over your symmetry line. We have a symmetry line. Use the symmetry line to your advantage. So we are going to reflect our y-intercept over the symmetry line. Once you have a vertex and 2 other points on the parabola, you can sketch in the parabola. Please just make sure when you sketch in the parabola that your ends don't curve in on themselves. That's really bad. You don't want it to curve in on itself. So it needs to curve around in a U shape, up and out slightly. Okay, let's look at our directions because there's some other things that they're asking us for. Does the graph have a maximum or a minimum value? What do you think about this graph? It has a minimum. What is the minimum value? Minimum. I definitely spelled that wrong. Wow. Minimum. The minimum value is -2. The y value of your vertex is your negative value, is your minimum value. The domain. The domain of all quadratic functions is all real numbers. The range is linked to your minimum value. The smallest y value is -2. All of the other y values are larger than that minimum. So y is greater than or equal to -2. They also want us to label the vertex and the axis of symmetry. I labeled my vertex already, so I'm just going to point at the axis of symmetry and write in x equals 1. Okay. I would like you to try example B on your own. Identify your A, B, and C. Now, sometimes it appears that there's no A value. If it just says x squared minus something, A is always at least 1. If there's no number shown in front of x squared, that means it's a 1. In this case, the number in front of x squared is 0.5, so your A value is 0.5. B is -4, C is -2. Your axis of symmetry is the opposite of B over 2A. So we plug in 4 over 2 times 0.5. You need to do the multiplication at the bottom. 2 times 0.5 is 1. 4 divided by 1 is 4. So our axis of symmetry is the vertical line at 4. Our vertex has to exist on the axis of symmetry, so 4 is also the x value of the vertex. To find the y value of the vertex, take whatever function you're working with and plug 4 into it. So 0.5 parentheses 4, closure parentheses squared, minus 4 parentheses 4, closure parentheses, minus 2, you should get -10. Did you get -10? So our vertex is at 4, -10, and I'm going to go ahead and label that my vertex is here at 4, -10. The y-intercept is our c value. Our c value is -2. So our y-intercept, our graph crosses the y-axis at -2. C equals -2. Your last step then is to reflect that y-intercept over the symmetry line. It's 4 units away from the symmetry line, so go 4 units in the other direction. And then you can sketch in your U-shape. Okay, the directions tell us to graph the function in standard form. Does this graph have a maximum or a minimum value? Minimum. And that minimum value is -10. Label, let's see, what else does it say? What's the order of those directions? Label the vertex and the axis of symmetry. My vertex is labeled. We simply need to label this as x equals 4. Or if you have it written somewhere in your work, that's good enough. And then the domain and range. The domain, all real numbers. How about the range for this graph? Y is greater than or equal to -10. Notice the minimum value and the range are tied to each other. You may want to, at the top of your page, next to these, if the graph opens upward like this, your range is y is greater than or equal to your minimum value. If the graph opens downward, your range is going to be y is less than or equal to your maximum value. Those are good things to have in your notes.